Welcome to Manufacturing Tech Australia with Shane Williams and Paul Mason.
Welcome to Manufacturing Tech Australia. Thanks for coming on the show.
No problems, Jill. We're welcome.
So we're here at the Memko stand. You're the founder here in Australia. I heard you're 3D printing stuff on Collins Street, additive manufacturing. Sounds pretty awesome. Tell us a little bit about what you guys do.
Yeah, so Memko's been going on since 2007 and started initially in consulting engineering services and then transition into technology. We are Dassault system partner, mainly around product development, collaboration for large businesses, and then manufacturing. I grew up in manufacturing, mainly aerospace and composites manufacturing. I did promise myself never to do manufacturing again, but technology is rapidly evolving, and I think the old perception of what manufacturing is no longer valid in my view, and well, my ambition is to really change that view, what manufacturing is and what we can do, especially in Australia, where manufacturing has been going backwards for many decades. So I think the shift in technology, the shift in processes, materials, the time to market requirements, especially in our aviation sector, really allow us to innovate and integrate vertically from the initial concept or problem to having a finished product, say, within a day or a week, rather than weeks or months, which is normally the norm.
Yeah, so what sort of parts do you get involved with? Is it mainly additive stuff or a bit of anything?
Yeah, I started my career in composites, so I'm all in plastic, cabin interior components. In Australia, we mainly operate aircraft. That means we get involved in the operation, in the maintenance, the sustainment part. So we trying to address the problem around the cabin, which is usually what the passenger sees. I mean, you don't see the brackets and the fittings, and what we see is the bits around you, which is usually the seat, the table tray, the seat rest, and the covers, and the impact of those things not being serviceable is quite significant, because if a seat is not functioning, that means it's unserviceable. The airline is not able to sell their seat. It's loss of revenue. So it's quite significant impact in regards to the operation. So that's an area that we're trying to integrate our digital technology knowledge, our engineering knowledge, and our manufacturing know-how to deliver a solution to the customer.
Cool. So what kind of solutions are we talking in terms of are they printed parts?
So one example is this armrest. So this is our Airbus A320 seat that consists of the sub part here, and which is one part, and then fitting to that is a sub plate. So this is the plate that is mounted and screwed onto the base. And the original part for this is a flexible rubbery kind of component that slips over this. And the problem is that it's not very well designed to start off with, and then because it's not supported on the surface all the time, as the passenger sits there and with the fingers pushes up and down, it starts cracking along the lines here, and then disintegrates like a piece of spaghetti. And the OEM lead time for this item is about 60 days. So you got 60 days of not service in the cabin, and I'm not sure how you feel as a passenger when you enter there and you see the armrest disintegrated or patched up. So it's a gaffer tape or...
Wouldn't be happy if I spent $2,000 on a ticket or more, would I?
That's right. So that was the problem statement, and then we said, well, why don't give it a go and find a suitable process and solution where we can deliver a certified, approved part that we can install on an A320 aircraft seat.
Wow.
And what we came up is this 3D printed component that doesn't look like anything like the original, so it's not a matter of copying or reverse engineering. Of course, we have to engineer the way
the interface and the way it connects,
an interface and connect, but other than that, this is our original design. So it just mounts like this. You slip the plate on the back like that, and then you take the armrest here, you slide the front bit in,
Beautiful.
And that's how it looks. And then you have the 3 bolts to attach it, and when you look at that, it looks quite presentable.
Yeah.
Another innovation on this, because we didn't really want to do any sanding or painting, because a painted surface. This is a high-wear surface, so imagine scissors with fingernails, kids dropping things. So having a painted surface is not a desired thing. And as printed surface is quite good, but it's not that resistant. So if you scratch it, so we use vinyl that we wrap.
Vinyl wrap.
So we achieve this nice finish, which is consistent, very resistant, and you can use any cleaning agents without that. And in the future, if it does fail, you only have to really replace the cover, the wrapping, which is only a few dollars rather than having to replace the whole armrest. So that's
nice.
So that's the beginning of that. And
so it was one thing to print it, but certifying it for use in the air, like how do you actually do that on a 3D printed part?
Yeah, so you have to build a system around that. So you're quite right. The printing, where everyone is focusing just on the material and the printing and the manufacturing. Overall, that's the easy part. The more difficult part is how do you create the engineering and substantiation that it meets all the requirements. Cabin parts, obviously this requirement here is not so much from a structural perspective, even though there are some abuse loads because people lift themselves up, and some of us are larger than others. So it has to carry some load, but it's not the driver. The driver for cabin is for this part is mainly fire, smoke, and toxicity. So if there's a fire in cabin, the material that we use here has to be fire resistant to a certain degree, and so for that we manufacture test pieces, and in this case it's the 3D printed part plus the vinyl, so we have to prove in a lab, accredited lab, that it passes the vertical burn test for duration. And then we have a certificate that goes with that, so that meets that requirement, and then we have to go through the engineering phase to prove that it will carry the loads.
Yeah, makes sense. I guess there's chemical resistance, scratch, and all that other stuff that with user interface
so
parts.
So we produce the certification report, and then we have the delegation from a civil aviation. And the vinyl, the good thing.
Yeah, it's nice, isn't it?
You can achieve any finish, so you can have wood veneer, you can have marble, you can have leather, any color. And then really if you want to generate some additional revenue, you can have advertising. You have customized message or image in there for movies or whatever, like we're doing on the stowing bins to some degree. So that was our first project, and then more recently we're working on a table tray. Again, where it's clearly OEM design issue. But the key here is that we can vertically integrate from the initial problems to delivery because of the Memko overall capability in regards to the regulatory delegation from our Civil Aviation Safety Authority, our knowledge and know-how about digital engineering, and our knowledge of the industry and where we are. So that's the key, and we can respond within days, as I said.
So I guess with Memko, what's in the future now? I mean, if you're already sort of digital twinning and simulating and designing and replacing, what's 5 years from now for Memko? What else are you guys going to be working on?
As I said, when we started the business, we started sort of consulting services, digital technologies. Now we are slowly integrating all that to create our own products. The additive manufacturing is one part. The other one is flight test instrumentation here, which is a device that we created for flight test instrumentation. Again, transforming it. Usually you have a wired system, instrumentation system for flight testing. Ours is wireless. So the power, the storage, and the sensor already embedded in this small device here, which is mounted on the surface of the aircraft. And we just launched a few months ago. So the aim, I guess, is to become an OEM, original equipment manufacturer in our own right for aerospace. We are only really working in aviation aerospace, and we create products that have a global appeal. We already have an office in Singapore, and we had a company in India since 2015. So our aim is really to be globally significant in that regard, even though we are small with about 70 staff currently, but the aim is to be continue innovating, become the original equipment manufacturer with a global impact rather than just locally here.
Makes sense. Sounds like a great success story.
Yeah, thank you.
Thank you. Thanks for coming on the show, Miro.
No problem. Thank you very much.
Cheers.
Thank you.
Thanks for tuning in to Manufacturing Tech Australia with Shane and Paul, recorded on the traditional lands of the Bunurong and Wurundjeri people. For more information, jump on the manufacturingtech.au website. Remember to hit the follow button to join us again next time as we continue to explore the intersection of manufacturing and technology.